Hello, viewers and listeners. Welcome back to another episode of Slaves to the Algo. I'm Suresh Shankar, founder and CEO of Crayon Data, an AI and big data company, podcaster, and host of Slaves to the Algo. Slaves to the Algo is my attempt to demystify the age of the algorithm. I plan to share my learnings, those of leading experts in the field, professionals who have delved deep into the subject, understand how they are using and how they are being used by algorithms in both their personal and their professional lives. Today, I'm particularly delighted to have Dr. Alok Aggarwal. Alok is CEO of Stry Analytics, a company that provides AI-based products, solutions, and services across industries. But Alok is a very interesting person because for me, he's personally a geek, a computer scientist, an algo person for a very long time, 4 decades, in fact. He started his career. He did his PhD in electrical engineering and computer science. He worked at the IBM Watson Research Center when IBM Watson was literally the fount of so many patents in the world. He set up the AI lab for IBM India, the research laboratory. He co-founded one of the world's first data-led research firms, eValueServe, and he currently is the chairman, CEO, and chief data scientist at Stry Analytics. But one of the reasons Alok is here today is that he has added the role of author to his list of achievements. He has written or is writing and will soon be launching a book called 100 Years of Artificial Intelligence. You're right, that's 100. It's not new. 100 years of artificial intelligence, past, present, and near future. And I've had the privilege to get an advanced copy of the book and read some of its stuff, and he explores the rise, the fall, the return of trends. And so I'm really delighted to have a trailblazer in AI and analytics, Slaves to the Algo today. Welcome to the show, Alok. Thank you for your time.
Thank you for having me, Suresh. Really delighted to be here.
Alok, I know you're a professional, but I always like to start my episode by asking guests a slightly more personal question. We're all professionals. We do work for companies. We teach, we mentor people. We write books as you are. But we're also affected as individuals by the development of AI. And if you look at your own life, and you've seen this in 40 years, can you just share with us some examples of what I would say, some great algorithms that you've come across and how it's impacted and whether it worries you or whether it affects your life positively or negatively? I mean, the Google search algorithm box is one of those great ones, but everybody knows about that. But any others that you think are really impacting life today?
So thanks, Suresh. So I think deep learning networks is probably, in my view, one of those algorithms or networks or systems that is just amazing. And people often don't realize artificial neural networks were invented in 1950s, put to test as perceptrons. Deep learning networks were not that much behind. In Soviet Union, Professor Ivahenko and Lapa actually wrote the first paper on deep learning networks in 1965. And they also actually created a deep learning network theoretically with 8 layers in 1971 and taught how to train them. So it goes as back. I mean, people often think this is something new, but actually it's not. And why it's so interesting is that by themselves, the theory was there, at least the beginnings of the theory was there, but we couldn't really make them practical because Moore's law was in effect at that time. Semiconductors were just coming out. Most of the work in 1965 was done by using valves, which were like bulbs in 1945 or during Second World War and continued until 1965. And building these networks and training them was prohibitively expensive. In fact, building a network with 86 billion neurons of the size of a human would have cost the entire GDP of United States in 1976. Wow. So, and Moore's law is, although I like to concentrate on algorithms, you cannot actually separate them out from what was happening around. And Moore's law has basically reduced the cost of computing and of storage by a factor of 1 million. And suddenly you have something which you can really train very quickly and you can really use very effectively. And deep learning networks have become ubiquitous.
So the deep learning network is your favorite algorithm?
Absolutely.
Could you just
and I think it is going to have many effects.
Yeah, could you give us one example of somewhere where the deep learning effect is a deep learning network is affecting us as, let's say, consumers or as business professionals?
So computer vision is probably the biggest one. I mean, pretty much all computer vision algorithms have underlying as deep learning networks. If you go into more details, it's really affecting autonomous car driving. It'll affect natural language processing very soon. I mean, a large number of deep learning networks have come out. What we call in the book as gigantic networks have come out. And given the amount of data that can be used for training, it'll affect pretty much everything that we think of in terms of vision, audio, speech to text, and of course natural language processing and generation. Yeah.
Alok, that brings me to, I think, your achievements and also what you're working on. Your past, your present, and your future. And I'm really going to start at the future because of the very near future, which is your book. And I love, I spent, a little bit of time over Christmas and New Year going through all the chapters. I know you're not completely done. What's very interesting for me is when I opened it is that, and, people tend to forget, right? I mean, you just mentioned it. Everybody thinks that all this is new. I invented AI, and, all youngsters seem to think that this is what it is. But you dedicated it to the memory of Alan Turing, Marvin Minsky, and John McCarthy, who literally created the basic science behind this, 7 decades ago. And, I remember Alan Turing in 50, we still talk about that. He says, can a machine imitate human intelligence? In 61, Minsky wrote, within our lifetimes, machines may surpass us in general intelligence. You've seen the revolution. You've been in it for 40 years. When you look at that, I think they predicted a chess machine would beat computers way back in 10 years, and that was in 1958. It took 40. So how far do you think we've progressed on this whole kind of prognosis that Turing and Minsky and McCarthy had?
Well, in terms of prognosis, I mean, I would like to say machines have done well in 50, 60 areas. Again, deep learning networks, other algorithms have done with lots of data, and the fact that Moore's law has been instrumental in making computing and storage cheap has done very well in that respect. But if you look at what Turing was thinking about, what Minsky was thinking about, and Minsky, by the way, was an advisor to the well-known movie 2001 Space Odyssey, when you have HAL 9000, which is the artificial general intelligent computer, which acts like a human, has emotions like humans. If you think from that perspective,
Alok, don't you just love that line in that movie where the computer says that must be human error?
That's right, exactly. I mean, and I write that in the second chapter of the book. I mean, we say that must be attributable to human error, and so it's a very, I mean, for people who are interested in looking at the history of AI, that movie is worth looking. I mean, definitely worth seeing at least once, if not a couple of times. And particularly because Minsky was an advisor to the movie. And that makes it even more interesting, because that was the thought process Turing had. He gave the imitation game, as you said. And in 1952, in a BBC interview, he actually said that he believed that by the year 2000, 7 out of 10 jurors would be fooled by the computer. So he actually believed that 2000, this would happen. An artificial general intelligent computer would occur.
And when do you think it's going to happen? Is it 2030? Is it already? Is it 2040?
So this is a very interesting question. So these guys, and that's why I credit them a lot, and I actually, the first few chapters are written in their memory, because I think they were geniuses and pioneers, but they had it wrong. And I mean, that's the part of hype and getting all caught up in it. So these guys were really, Turing unfortunately passed away in the early 50s, but McCarthy and Minsky continued. And then, of course, they would have massive discussions in MIT with social scientists and others, and who said, look, this is not possible because humans have emotions, and to have emotions, you have to live like a human. And then the hype was there in 1960s, 50s and 60s, and it went down in 1970s. And a very interesting article came out in 1977 in New York Times, a newspaper. The reporter asked John McCarthy, when do you think, because by that time the hype had gone bust, And he asked a very interesting question. So, sir, when do you think artificial general intelligence would occur? And his answer was equally deep. He says, perhaps in 5 years, perhaps in 500 years. What you need is 1.7 Einsteins and zero point 0.3 Manhattan projects. So he realized by that time the gravity of the situation, that you really need, I mean, seriously, you need paradigm shifts. Like Einstein created a massive paradigm shift to what Newtonian physics was. And he pointed out that it is 1.7 Einsteins. And by the way, Manhattan Project was the largest project of its kind set by the US government in 1930s, late 1930s, early 1940s, which created the atomic bomb. And it was at that time worth about $2 billion, the largest government project ever funded, worth about 25 billion if you take inflation, or 30 billion if you take inflation into account. So 0.3 Manhattan projects to me seems like on the low side, because that's $9 billion today. Just for research alone, even that for the world is a relatively a low number. Probably it may be more like 3 or 4 times Manhattan project. The more important part is the paradigm shift, the 1.7 Einsteins, which we don't have anywhere close. So yes, deep learning networks and other algorithms and data would help us in many, many places where we need help, where they will make us more efficient as humans. But getting to artificial general intelligence, I don't see it happening in any time in the near future, because I don't see even 0.3 Einsteins anywhere.
And I'm going to come to that. I think you made 2 or 3 interesting points, and I just want to go a little bit deeper on them, right? You made an interesting point about, they were wrong. But, perhaps we should look at it differently. Turing and Minsky weren't wrong in terms of the direction or the scale. Possibly they were a bit off on the timing. And which brings me to the other point that you made. I don't even know that they were off on the timing. It's just that for AI to work, you need a lot of component technologies to come into place, the cloud, the chip, like Moore's law, all of these things. And perhaps it is those physical laws, the things that are still rooted in the physical world, that have perhaps meant that it's not 40 years from when Minsky said something, but maybe it'll be 70 or 80 to get there. So that's to me a big takeaway from what you're saying, that perhaps these people have been, even to envision this in 1950, when there was the IBM 360 wasn't a thing then.
And yeah, absolutely. And that's exactly why I call them the 3 fathers of AI, because imagination, knowledge is extremely important, right? We all strive for knowledge. We read books, we go to classes, we continue generating and learning via books and other means, all the knowledge. But what trumps everything is imagination. Imagination always trumps things, right? Einstein came up with the new ideas. That was his imagination. So imagination trumps knowledge. And these 3 people were imaginative to even think about it in those terms is interesting to me. Now, whether artificial general intelligence will happen in 40 years, 400 years, or 500 years, as McCarthy said, I don't know.
Where are you placing your bet on this, Alok?
My bet is probably doesn't matter whether it's 5 or 500. I think we should look at it from purely from a selfish perspective of being humans, that we want machines, AI, or whatever we want to call it, to work for us. And we already are in that stage when they're already helping us improve many of the things that we do. Many of the menial tasks that we do will be taken away, which will free up people to do other interesting things, whether it's art, whether it's surfing, whatever. So it'll open up many other areas, and it'll seep. As I write in my book, it'll be very much like the Industrial Revolution, when first steam engines in the first revolution became pervasive by mid 1800s, late 1800s. And then, of course, was the case with motors. Today motors, there is a motor running in my laptop. We don't even think about it. I think AI will be pervasive by 2049, and that's partly what the 100 years are, from 1950 to 2049. So nice, when will AGI happen? I do not know.
I'm going to come back to some of those themes, but you mentioned something very interesting to me also. And you said people have been saying, how about human beings have emotions, and machines will not be able to do some of these things, when these pioneers talked about it. Do you think that today we are actually starting to see the manipulation of emotions, and and we start to see it with some of the areas that people are using AI and do it. Do you think that machines will learn to read human emotions? If you read, and I know you're a voracious reader, you talk about Kazuo Ishiguro, he talks about artificial friends and things like that. Do you believe that machines will also learn human emotions?
I don't know. I mean, I personally think even humans have very hard learning human emotions. I mean, somebody may be smiling and may be thinking something different. So I think, I was having this discussion with another person. I think a lot of it is our human biases coming from a particular country. I mean, it's well known now that when Indians say yes, they typically nod as if they were saying no, and then they would say yes. I mean, how does a human who doesn't know the context figure out that, okay, this guy is an Indian,
And
he's saying yes and nodding in from left to right rather than from top to bottom, right? So,
Alok,
and
I
then I
really
have my
wish.
doubts about machines. I mean, if we are so wrong about emotions, I mean, if we were right, I think the number of divorces, the number of issues that humans have with humans would probably go down so dramatically. We probably don't even understand ourselves, forget about understanding others. So having machines
That's
understand.
probably the single best thing I've heard on my podcast, that humans don't understand emotions. How do you expect machines to?
I mean,
Uh,
isn't that a fact? I mean, don't husbands and wives say to each other, especially wives, I would say, I mean, nothing against them, that you don't understand me. You're not listening to me. You're hearing me, but not listening to me. So, I mean, if that's the case, I mean, now you put in something which is made of semiconductors, not even carbon, hydrogen, and you want that to understand. I tend to agree with the social scientists of the 1960s when they did not even want to talk to Minsky and McCarthy at MIT. It's a well-known old story that they would not even sit at the same table. They used to fight so much on this issue. And there may be some truth to it, to what social scientists were saying at that time.
That is absolutely. Moving on a little bit, Alok, I think into another area, right? In your book, I think one of the most interesting chapters to me is that you talked about 40 different subfields in AI: rules-based systems, NLP, machine learning, speech recognition. And it strikes me as a practicing professional. I'm not anywhere near the academically deeply knowledgeable person that you are, that most of what passes today for AI is simply a rule-based system that has been codified by a human being with their best knowledge of what they think the rule should be. So would you tend to agree with that? Do you think, systems are moving beyond rule-based? Where do you think, what are the other subfields that you think are going to be, I think, the de rigueur in the next, if I take the next 2 or 3 years, which ones do you think are?
Yeah. So I agree with you completely. I think 80% of the companies, probably even more, we were doing some survey very recently, who call themselves AI-based companies, actually used expert systems or rule-based systems. Nothing against that. That's part of AI. We should not take it in any wrong way. In fact, that was the second hype that got created in 1980s and created a second winter, because they created a hype that rule-based systems or expert systems would effectively be the next way to create artificial general intelligence, and soon that flopped also. I mean, it was a small hype and it was a small bust, but I remember very distinctly coming out of my PhD that I was told, don't sell yourself as an AI expert because you won't get a job, because the second hype was almost going bust.
Isn't that just reversed
So
today? Even if you don't know AI, you sell yourself as an AI
yeah,
expert.
exactly. That's part of hype and bust, right? I mean, your boom and bust. So you have to figure out which side of the cycle you are on, and you present yourself accordingly. So, and then nothing wrong. I think part of the whole thing we have to realize, and we often forget during hype cycles, especially, that it takes time for technology to seep into human lives. It is not an instant thing. We think that, okay, autonomous car driving, Google is running its show and others are running their shows in Silicon Valley. They're training these cars. You see some of these cars being trained on the roads and highways, and you say, okay, they will be here in next 2 years. The likelihood is they won't be here in the next 10 to 15 years, because it takes a long time to seep for various reasons: rules, regulations, how humans perceive it, and so on. And from that perspective, I mean, it's not surprising that something which was there in 1990s by 2010 became the commonplace thing. My feeling is a lot of the stuff that's happening now will become commonplace in 5 to 8 years from now. Not necessarily autonomous car driving, but some of the aspects that I was talking about, computer vision, for example, radiologists and cancer specialists may use vision systems to detect which portion of skin cancer is actually cancerous or is benign, which portion of the mole is benign versus cancerous. I think some of these things will begin to gradually seep down. I think dentists will begin to figure out, or at least take, I mean, it won't be that the AI will be making all the decisions, but it will be a decision helping system. I mean, like recommendation systems that, okay, Alok's x-rays show this, maybe he has a tooth decay problem here. And that's a decision helping system rather than a decision.
And that's very interesting because I think it's going on to something, Alok, that I wanted to get you think. Last year, we had actually a couple of different people on that, and one of them was a doctor. He's a medically trained doctor who's also studied information systems and artificial intelligence and an MBA, very interesting man. And he talked about the idea of augmented intelligence, which is what a recommender system or something that, a system that basically tells the doctor, hey, this could be 4 or 5 different things. These are the probabilities, these are the reasons why. And then the human being applies the judgment that the machine still is not able to do. And I guess the question, therefore, is, a lot of concern around this whole thing is, will AI replace human beings or will it augment human beings? And my question to you is, you talk about in your book about 40 domains where AI programs perform on par with human beings today. Could you perhaps share some of those things? Because I think it'll be,
a very interesting one is from Mount Sinai Hospital, very well-known hospital in New York City, probably in the top 20 in the US, if not in the world, both from teaching and research perspective. And they created, using deep learning networks in 2015-16 timeframe, they created a particular network called Deep Patient, where they trained it on people with various kinds of mental issues and problems, and actually it actually detects onset of schizophrenia better than psychiatrists. And it's one of the well-known things that we really do not understand. We do not understand most of these mental diseases well, and the very fact that so it could be a very good example where, again, a psychiatrist may want to take that into account. Again, it's not a decision-making system, it will be a decision aid system. So that's I think, a very useful place. Similarly, autonomous car driving may be, I don't know, in my view, at least a decade away, but at the same time, the car making decision, telling the driver to not go into that lane because you'll have an accident, or not go into that particular highway because that highway has more accidents on a probabilistic way, etc. Many of these things, the likelihood is that since they're doing so well, they will be used more and more by humans in the commercial world, in real life. Another example is answering questions. Again, the way the natural language processing systems are improving, they are actually becoming very good at question answering. Not about emotions, again, not about legalese, but if you ask them very specific questions, they are particularly good, almost at the level and sometimes beating humans.
But because look, that's an interesting one. Then as you rightly pointed out, your whole book is about it. There's always hype, and then there's the fall, and then there's the actual catching up with reality, and then suddenly one day you find it's very big. But you talked about this whole natural language processing, and and chatbots, which you have the new thing about 4 years ago, 5 years ago. I have not met a single chatbot that is able to kind of understand, something where the state is very specific and known, that is able to adapt to the state of what the question is today. Yeah. Do you see advances being made like that? Yet on the other hand, I'm seeing the progression in things like Google Voice Assistant and Siri and things like that, which seem to be getting better, but they seem to be better understanding the speech to text, not necessarily understanding the context of my question, which is what a good natural language engine should do.
And that is precisely the problem with deep learning networks, right? Deep learning networks by nature understand patterns. So they are trained to understand patterns. They're not trained to understand concepts. So according to, along your lines, you train a deep learning network for autonomous car driving on stop sign, the car should stop. Now, there are experiments that Carnegie Mellon professors, university professors did, I think about 4 years ago, where they put a stop sign on the second floor, or not on the ground floor, but on the floor above it. They put a stop sign in the window and the car stopped. I mean, this is, again, talking about context. And again, it goes back to what these social scientists and non-computer scientists were saying in 1960s, that we humans understand the context fairly well, and your networks so far have not taken context into account. That was the case in 1960s, and that is still the case. Our deep learning networks, our algorithms, other algorithms don't take context into account. Whereas somehow we have a context. Suresh and I met somewhere in a conference. We will remember, maybe I don't remember the name, but we'll remember, oh yeah, I talked to this guy and we were talking about these things and so on. And that is very strongly missing in pretty much all algorithms. And I think that will be a hard thing to figure out. And
so, Alok, there's an interesting conversation I
hope.
had, and I want to ask you about this because you're also this mix of a academic, a practitioner, and a business person. And one of the conversations I had with one of my earliest guests on Slaves to the Algo was about why is it that lots of companies that actually have the data, actually can say, understand 10 context because they have data, they have huge amounts of data, do not necessarily apply that data and that pattern thing to solving a real problem, right? And I asked this in the context of the Google search. I said, if Google knows everything about me, which it should do, why is it so hard that I have to do 8 clicks to get somewhere? And the gentleman, John Kim, he's the president of Expedia Marketplaces. And John told me that's because the business model pays you to click the ad. They want to show you more ads. They don't want to get you to they want you to get the answer, right? And I mean, again, no disrespect for Google, but I'm saying so much of times it doesn't seem to be about what the machine can do or what the data set that exists, but about the business model preventing that from happening. Do you see examples of that?
Yeah, I think there is a lot, unfortunate. And I can say it is unfortunate, but perhaps that's part of economic revolutions or economic movements. I think, everyone will use it to their best advantage to sell more. I mean, it's no different between Google or Netflix. I mean, the recommended systems will show me the same movies, same type of movies that I've recently seen. Unfortunately, many times they're wrong. I mean, Facebook is no different. So I think recommendation systems by nature are likely to do that. And the advantage recommendation systems have is, of course, they can sell more of their ads or more of their product in the whole process. They think I like it, and therefore I may be tired of it, but they would try and sell me more. So I think that is one of the issues that, in a sense, for the world to figure out, from a society to figure out. But I don't think that will stop, in my view, at least, the progress of AI algos and data in getting new answers or new, more effective solutions.
And as you see this progressing, Alok, I think, again, this is something you talk about. And, we've had several guests talk about this fact. And I think many of them find that, and for me personally, this is the most fascinating aspect of the development. It's got nothing to do with the technology. It's got nothing to do with the data or the algorithm. But the idea of explainable AI, that when you give me something, you should tell me why you did it. And while today a lot of that is about doing so from a regulatory standpoint, that you should be able to explain to a consumer and whatever else it is, I find that this is almost the basics of something, right? I mean, if I'm talking to you and I'm wanting to talk to you and convince you of something, I have to give you my reasons why. And how do you actually think the tech industry, how do you think AI industry is going towards this whole idea of explainable AI? I feel it will come. I feel it will come sooner than later. Most people tell me I'm living in a fool's world. But my thinking is, in the 70s, food labels didn't have anything. Now you won't buy anything without the food label telling you what the ingredients are. So will we soon have that, what are the ingredients of this thing soon enough? What's your take on this?
I want to. I don't want to disappoint you, but I agree with your other guests who said you may be living in a different world. I actually, after the hype in the second chapter, I write that one of the things is we don't understand human thought. And in fifth chapter, where I talk about deficiencies or limitations of contemporary AI systems, I say we don't understand machines either. And so we have now a double whammy. So going back to your point that you want to understand why I came to a conclusion, let me ask the following. My wife happens to be a medical doctor, and I asked her this: do you explain to your patients what made you think that she is breast cancer stage 4 versus stage 3 versus stage 1? And her answer was no, we almost never do. In fact, doctors around the world have a very interesting habit, I mean, call it bad or good, depending on how you want to look at it, of not explaining to their patients how they came up with a particular disease, or what are the symptoms, and what are the why they should believe them. I think it is a matter of trust that we do it. And my own feeling is, and this is where I go back to the whole issue about AI systems beating humans. Let's take it 10 years from now. And suppose the system is giving better results, more accurate results about skin cancer than a pathologist or a cancer specialist is. By nature, wouldn't humans say to the doctor, did you consult this particular AI system? Is that what it is saying also? Or would they all not say that, look, this is malpractice, doctor, you did not consult the AI system? So wouldn't it work?
But Alok, isn't that what we do when today people do a CT scan? When people say do a blood test, they ask for it, or in fact, the doctor himself says, let me use that and explain that to you. So it may take time,
will they even say that, doctor, I want to understand, explain me why you believe I have stage 4 versus stage 3, etc. I think my own feeling is that explainability is very important for many reasons. We do want to understand causes because we can probably extrapolate it to, if I understand how a particular algorithm came to a particular conclusion, maybe that understanding would help me in other areas. Maybe if it said, look, this person has this kind of a cancer, and if it gave me the reasons behind it, I may be able to actually explain it to a different, in a different setting altogether. This is what humans are good at. Again, it goes back to imagination and other areas of human intelligence, which AI is nowhere close. Explainable AI is very, very hard right now. It's almost, it's trying to figure out what kind of a polynomial the system is computed using a multi-layer network. And at least right now, that seems like a very hard thing. People keep saying, oh, I have an explainable AI system. But when they say that they have an explainable AI system, they are not using then anything more than linear systems, to use some mathematical terminology. They're not using any polynomials, etc., because we have almost no understanding of it. They're approximating what the AI system is doing by another system which is more linear and which is more explainable, and they may be off from each other, and that's fair.
And that's fair. It's a bit like you're taking a graph and you're rendering it as a series of, with a lot of complex relationships, and you're trying to put it into a very simple set of things, which is hard.
And in the whole process, you may lose some accuracy. You may not be as accurate, but at least you can explain to yourself. So that's the second, in fact, that's the second thing we discuss is interpretability. They're probably interpreting what the machine is doing, not really explaining what the machine is doing.
And that's a lovely distinction, actually, because if you look at it and you use a wonderful word, you said, when you go to the doctor, you trust the doctor and you don't necessarily ask. But I'd learned to trust the doctor over time, or I go because of the hospital, I go because of the credentials.
That's right.
And somewhere interpretability and explainability are key elements of trust. I need certain source credibility. And this is, I think, and I'd like to get your view on that, which is, this is one of the big issues, I think, that the AI or the data industry faces, right? Which is, can I trust you a little bit more? Can you tell me a little bit more? Can we have a little bit of a conversation? You can't have it with the machine or an algo, but you know what I'm saying? The human being who stands in between, can they help interpret this stuff for us a bit more?
So absolutely. So I actually in that particular chapter, I talk a lot about this whole issue, and my view is several fold. One is that trust takes time to build, whether it's humans trusting other humans or whatever, right? I mean, we see it in our daily life. I mean, to trust another friend, you have to have some longer relationship. The same will be true about machines. You will have, I mean, humans will begin to trust machines if they're consistently better than the humans. The other aspect is certification. You trust a doctor if the person is, let's say, an MD from or a fellow from Harvard. You will trust probably, I mean, just the stamp Harvard probably makes you trust the person more than if the person is from some college in Singapore or in India and so on, right? So I think certification is a very important
don't
aspect.
say that. We believe our system in Singapore is fantastic.
Oh, I'm sure your system is very good, right? And that is again another aspect, right? Who is trusting whom? And so again, the context comes into picture, and you nailed it actually, because I was going to say who's trusting whom and under what certification. Maybe a guy who is sitting in India who doesn't know Harvard at all may trust somebody from the best college in India or the best college in Singapore, similarly, much more than somebody in Harvard. So I think certifications matter. And my own view is that there would be a certification industry that will come out. Just like another industry that will come out is, hey, this doesn't have the biases. When biases are we are looking at these particular characteristics, let it be ethnicity, race, age, etc., etc. Similarly, a new industry is likely to come out, which would be a certification industry of sorts for machine learning algorithms. Just like we have a certification for accountants and for engineers, professional engineers, doctors, and so on.
And I think that is one thing. Something like this, Alok. I mean, I presume a lot of this will happen from the United States. Are there industry bodies? Are there companies working towards this, or you think it is something that will kind of will it happen soon?
I think that's why I'm writing near future. My own view is that it will evolve in the near future by 2049. Another area which I think will emerge, which I don't see it, will be professional liability insurance. That just like medical doctors have in US have malpractice insurance. So if I, as a medical doctor, do something really wrong, then I can be sued criminally, but also financially. I think and product insurances are of the similar kind. I mean, if car goes berserk, I mean, you can sue the car maker. I think the same kind of insurance of various kinds would come out for AI systems as they begin to be used. And that has not happened either. So, I mean, again, in my book, I say, look, some of it is obviously futuristic, and it may give ideas to people to set up companies, which is all the power to the world and humans. Because to me, ultimately, AI is all about humans, and we have to make it work for humans.
Absolutely. And look, it's been a fascinating. I have at least 20 more questions, and maybe we'll have you back on the thing, once you get the book out into the marketplace to talk more about it. But I do have a couple of, I think, ending questions, right? One of the things that's happening in the world is this whole rise of machines and sensors, right? IoT, smart cities. When you have a machine-to-machine interaction, because now you don't have the human being in between, is there actually less bias, or is the bias magnified because now there's nothing even to control or add context between the signals that are passing between machines and the decisions that are being taken by machines?
Yes, my personal, I mean, this is an area of research right now. This is a fairly, I mean, people in various colleges and various research institutions are working on it. My personal belief is that it is likely to be compounded. The reason is both machines, unfortunately, are trained on data which itself has bias, because after all, humans are training it and we are biased by nature, so we are training it. That's part of the data having bias. But there is another bias that unfortunately explainability creates, and that's part of the problem with unexplainable AI, is there may be a pattern that the machine finds out, which we do not even know of, right? I mean, suppose without realizing we are sending, again, going back to healthcare, we're sending a lot of mammograms from a few hospitals, let's say 20 hospitals. And in one hospital, there are more mammograms with cancer. The machine may learn that this particular hospital has more cancer patients by nature coming in, which may not be the case all the time, right? So it may become biased about that particular hospital. Much worse would be septic systems, right? I mean, hospitals generally, unfortunately, they try to avoid sepsis a lot, but sepsis happens. And that machine could get biased about, hey, don't go to this hospital because it has a lot of sepsis, whereas the underlying cause could be very different, and it has suddenly become biased without us realizing.
No, it's such a fascinating thing. And look, I think there's going to be a second conversation I want to have, probably going a little bit deeper into some of these areas, closer to when you're ready to launch the book. But I do have one question for you, which when I read the book over Christmas and New Year, I left with this question. In the 50s and 60s, you had Minsky, you had Turing, you had McCarthy. And you haven't covered this in the book, and so feel free not to answer it. As you stand today, 70 years on in 2020, and you're writing a book that's going on to 2049, do you see people of that stature, people who are trying to say this is where the future is going to be? Or are we all kind of somehow become, in this era of corporatization, is it all becoming about people sitting in large companies and building things that make money for them? Do you see those visionaries again?
Absolutely. I think both of them go hand in hand. I mean, that is how I start the first chapter, Structure of AI Revolutions. And I talk about AI revolutions, not revolution. And one is a scientific revolution, one is economic revolution. So economic revolution is very similar to industrial revolutions that have taken place. And scientific revolution, I give the example, and there is a very, very interesting book by Thomas Kuhn from 1962. The title of that book is The Structure of Scientific Revolutions, when he talks about how you have Copernicus and Newton giving the first paradigm. Then for 200 years, the same kind of paradigm continued till we had a lot of anomalies we could not explain, and we had eventually crisis after crisis in late 1800s we could not explain. Simultaneously, by the way, the industrial revolution was going on in full force, right? The economic revolution of steam engines and then mass production, etc., was going on. I mean, and yet we had a massive, if you look from the scientific perspective, we had a massive vacuum because, I mean, suddenly Newtonian mechanics or Newtonian physics did not work anymore. And then you had an Einstein. And I think that's why McCarthy came up with this 1.7 Einsteins, because he was probably, Kuhn spent a fair bit of time in Berkeley and at MIT. So I wouldn't be surprised if McCarthy had some discussions with Kuhn, because otherwise coming up with this notion of 1.7 Einsteins and zero point 0.3 Manhattan projects, to me looks really, really deep. But he might have had those discussions, maybe not. So I do think that will happen. I think there are already some of the very well-known people in the deep learning network field, like Jeff Hinton from Toronto, believe that we pretty much have achieved whatever we could achieve with deep learning networks, and we need to move forward. So I think that the same anomalies and crises are going to appear with respect to all the algorithms that we have currently. And gradually, when anomalies happen, sooner or later, there are people who would try and create a new paradigm.
That's wonderful, Alok. And I'm going to make a suggestion to you. You know, you mentioned the gentleman from University of Toronto. I think you should predict 2 or 3 of these visionaries who are going to be the next Minskys and Turings at the end of that book.
I would love to predict that, but I don't think I have either that kind of a vision to predict who will be the next visionaries. I mean, let's not forget, Einstein until 1905 was a patent clerk.
Absolutely.
In Switzerland, and nobody had heard about him till he wrote his theory of relativity, right? So I think that's probably the hardest prediction. Probably that's harder than predicting the stock market, in my view.
Thank you. Alok, what a wonderful way to end this thing. I think this has been such a fascinating conversation. I mean, the book is fantastic. I mean, the fact that you're talking about 100 years, the past, the present. I think you're talking about all these overlapping waves of hype and bust and next wave of hype and all of them going on in parallel. I just simply love the point you make about we don't know it'll happen, whether it's 5 or 500. I know McCarthy said
I didn't make it. I just thought McCarthy made it. And actually that made me write the first chapter itself because
Absolutely.
of the point because there are 2 simultaneous revolutions going on, right? I mean, there is an economic revolution, as you said, corporate world. I mean, we saw that with James Watt coming up with the Watt engine, the steam engine, and then everyone corporate. I mean, they couldn't care a damn about all the anomalies that were happening in the physics world, right? And yet there was the physics world, which was completely stalled. They said, okay, we have learned whatever we could have learned. The rest is up to God, and we don't think we'll learn anything.
Absolutely. So, and I think it's been really fascinating to talk about the fact that there is explainable AI, there is interpretable AI, the linear and binomial. So many wonderful topics that we've covered today. In spite of everything else, I think you and I are fundamentally hopeful people about the future of AI. I don't think, while we do know, I think the danger is that we could all end up being slaves to the algo. You in particular strike me as someone who is not a slave to the algo, is trying to be a master of one. Thank you very much, Alok, for being on the show. I'm sure we'll have you back on it again. And really been a privilege. And we're all looking forward to that book release coming out soon. Thank you for being on the show.
Thank you so much for having me again. I'm really delighted for this conversation, and definitely will continue it.
And to my viewers and listeners, I hope you enjoyed the show. Dr. Alok Aggarwal, CEO of Scry Analytics, author, a polynomial, a man with over 40 years of experience in AI, writing about 100 years of artificial intelligence. Slaves to the Algo is available on YouTube, Spotify, Apple Podcasts, and Google Podcasts. We release a new episode every week. If you enjoyed this episode, don't forget to rate, share, and subscribe. Stay safe. The age of COVID is not beyond us yet. And stay relevant in the age of AI. See you all soon. Thank you very much.